Okay, so I just remind you quickly again because we need that domain that we did. We did a couple of types, but we didn't finish it. So we are continuing with this section 2.2, which is the notion of the functions. Okay, so what we need to know is what is going to be the domain of the function. Okay, this is where we end up. Find the domain of each function. Each function. Okay, we talk about the function is a machine. It's a mathematical machine. The mathematical machine can do mathematical operation, adding, subtracting, multiplying, dividing, taking the square root, cube root, etc. Some of these operations are free, like adding, subtracting, and multiplying. But some of them are not free. If you want to divide, you are not free all the time because you cannot divide by 0. If you want to take the square root, you are not free all the time because you cannot find the square of the negative numbers. Okay, so these are the one that impose some restriction for us, but there are 4 types of functions. At the first one we talk about, let's give you more example. It's x to the 4th minus 18x squared plus 1. If you take calculus, this is a very popular function. You see that's type 1. We talk about this function called addition, subtraction, and multiplication. Is a combination of powers of x. So this function is called a polynomial. Polynomial functions are defined everywhere. Defined everywhere means you can use any number for x. Any number means any real numbers. Okay, no restriction. So this is how you're going to answer it. You're going to tell us that f is a polynomial. Okay, f is a polynomial. That's it. And so the domain of this function is R, all real numbers. Define everywhere. Replace x by any number you like. There is no restriction. Okay, any question? That was type 1. Just identify the polynomials. Type 2, a rational function. We get a quotient. G of x equal to, you see x on the top, something like x squared minus x minus 6 down the bottom. You see, this is a rational function. You have the, you have the polynomial on the top, polynomial on the bottom. So everything is fine except division. When you divide, you must be careful. The denominator cannot be 0. So there are some values of x that you have to exclude. Factor the denominator first. Okay. Solution is going to be g of x equal to x on the top. You want to factor this one. So this is how you factor it. You need 2 numbers. Product of 6. Since this is a negative, difference of 1. Give us the numbers. 2 numbers, product of 6 and a difference of a negative 1.
Negative 3 and 2.
Very good. Negative 3 and the positive 2. Because you multiply, we get the negative 6, and we add, we get the negative 1. So the number that are 0 at 2 places. X equal to 3, x equal to negative 2. You have to exclude those numbers. Okay? So, you don't have to, but this is how we find. It's going to be x plus 2 equal to 0. So that gives you x equal to 3, 1, and x equal to negative 2, the other one. So you have to exclude. Okay, this is the number line. You exclude the negative 2. Okay, exclude the negative 2, and you exclude the positive 3. So the domain is everything except negative 2 and 3. But we need interval notation. So the domain is 1, 2, 3 region, 3 portion. This region in interval notation is negative infinity to negative 2, union with negative 2 and the 3, union with 3 and positive infinity. So that gives you the domain of your function. Okay, any question? So this is going to be the case. Rational function, red flag. What's a red flag? Denominator cannot be zero. So exclude those denominator, those numbers. That's a type 2. A type 3 is going to be this one. You may given a fractional one, a rational function, but denominator would be stay the same. You see this one? 2x plus 1, x squared plus 16. You see, there is a denominator, but it's x squared plus 16. We try to factor it, because if you factor it, then you get the numbers that you have to exclude. But you know that x squared plus 16 is not factorable. We can only factor x squared minus 16. Since you cannot factor it, the number line stays the same. Okay, so for the solution, you say that x squared plus 16 is not factorable. It's not factorable. Since it's not factorable, you see, number line stays the number line. So the domain of this function is R, all real numbers. Okay, any question? So you may have a fractional one, but the special case is that x squared plus 16 is never zero. Okay, that is rational function. Question? Next choice is radical function. So what's going to be radical function? F of x equal to cube root. Okay, we get cube root of something like x to the 5th minus x minus 7. You want to find where this function is continuous. You see, inside the radical, it's a polynomial, powers of x. You know that the domain of the polynomials are all real numbers. So we can use the numbers here. But the question is, can you pull these numbers out of the radical? To do that, you look at the index of the radical. Index of the radical is an odd number, 3. Since it's odd, you can have positive number, negative number, okay, and 0. Because this is odd index. You see, cube root of 8 is positive 2. Cube root of negative 8 is negative 2. Cube root of 0 is 0. So we can have positive, negative, and a 0. So this means this function is defined everywhere. Okay, so that's the point about the radical function. So you have to emphasize that you did check the index of the radical. You see, index of the radical is odd. And so the domain of the function, all real numbers. Okay, all real numbers because you see the index is odd and the inside is a polynomial. Any question? So what would happen if it's even? You'll be in trouble. Okay, any question? So this is another case. When we get the odd index, even index. Okay, the even index would be like, what number is it? Okay, that was number 4. So we get to the number 5. Okay, we get to the number 5. We have a function f of x equal to a square root of. Okay, something like a square root of how about 2x plus 4. You see, inside the radical, 2x plus 4 is a polynomial. So it's defined everywhere. But the next question is, can you take this one out of the radical? We look at the index of the radical. Index, a square root, index is 2. When it's a 2, you know that. You cannot have a square root of a negative number. A square root of negative 4. No complex numbers, remember. A square root of negative 4 is not a real number. Okay? It's undefined. So you have to impose that condition. So the solution is, index of this radical 2 is even. Okay, when 2 is even, you are in trouble. Now you say that, oh, f is defined. F is defined, okay, if or when the 2x plus 4 is going to be greater than equal to the 0. So you have to guarantee that this number is never negative. So to guarantee it, you have to solve this inequality. Okay, move the 4 to the other side. That gives you a negative 4. Divided by 2, so x would be greater than equal to negative 4 over 2. So x would be greater than equal to negative 2. So that would form the domain of your function. But you have to give us interval notation. Negative 2 up. Negative 2 up to where? To positive infinity. Open, close. This is the domain of your function. Okay, so for the radicals, 2 cases. Index odd, free. You can use any number you like. Index even, you're in trouble. You have to impose this condition. What's the condition? You cannot have a negative number inside. Okay, no negative number inside. So we force it to be positive and we solve it for x. So x must be greater than or equal to negative 2 so that you'll be able, you'll be able to do it. Okay, any question? There is one tricky one, in calculus and even in your book. And it's a little bit technical. So we are going to have that one too. What is that technical?
Will we be required to graph number 5, like on the number line?
No. No number line are required.
Okay, so we don't need to do that for any of these?
No.
Okay.
But I need interval notation.
Okay.
I just put the number line so that we give you just to check. Okay, but make sure you give us interval notation. Okay, let's see what is special about this one. It's using calculus. Fourth root. Okay, fourth root of something like, how about x squared minus, minus 5. It's a popular problem in calculus. You see, the index of the radical is even 4. So we have work to do because you have to impose a condition that the inside is always positive. Okay, are you ready? Solution. We claim that the index of this radical 4 is even. When it's even, you have work to do. So work to do means x squared minus 5 must be greater than or equal to the 0. You see? So you have to work to get the x. You know that you can move the 5 to the other side. Take the square root. Radical 5. What is radical x squared? What's the square root of x squared? Any suggestion?
Plus or minus x?
No, you must have one answer only.
Absolute value of x.
Excellent. That's the one. Absolute value of x all the time. You see, you must have one number and you must have a positive number. So that's why it's always, you see, always absolute value of x. Okay? So that gives absolute value of x greater than or equal to the radical 5. Now, where are you? You see, this is home, if you like, 0. Radical 5 to the right. Radical 5 to the left. You know that when you have the absolute value, you are going to use positive, negative radical 5. But you just check, and when it's greater than, you see, greater than above the radical 5, above the radical 5. So you are here, and the like mirror image, and here. So these two portions would be the domain of your function. There is another possibility if they give you less. If it's going to be less, you are going to be between negative radical 5 and the positive radical 5. So you are here or here. So what does it mean? The here means negative infinity to negative radical 5, open, close, gap, or radical 5, and the positive infinity. So this would be the domain of the function. Okay, this domain is very popular in application. So from time to time you will see it. That's why to make sure that you have a couple of problems in your book related to this one. Okay, so be careful. We get the radical of the even index. This is a most involved one that you may be considered. If it was, that if it was 5, it's done. It was 5, it's odd. So it would be all real numbers. But when it's even, you have to guarantee that x squared minus 5 is not going to be negative. So force it to be positive. When you force, you may get the absolute, and the radical x squared is around all the time. So replace it by absolute value of x, absolute value of x, here, then go to the radical 5. It's greater than, okay? And when it's greater than, it's x is going to be above the radical 5 or below the negative radical 5 because of the absolute value. If it's going to be less, you are going to be between radical 5 and positive radical 5. You will see it on your practice one. Okay, any question? So these are various types. There is one in your book and related to this radical, and they want to test you if you like. Let's see if you are going to lose this one. That's what's special about this. Remember, we talk about the radical with the odd index. We say the domain is all real numbers. How about this one? You see, they give you x on the top, but they give you something like cube root of x minus 1. Can you guess what's the domain of this function? You see, the radical part, the index is odd.
All real numbers excluding 1.
Excellent. Very good. Very good. You see, cube root of x minus 1, because of the odd index, domain of this radical is all real numbers. But it's on the denominator, remember? You must make sure that the denominator is not 0. The denominator would be 0 at 1. So you have to take the 1 out, you see. That's it. So the domain is all real numbers except 1. With the way we write it down, it's going to be negative infinity up to 1, union with 1 and positive infinity. This is a very popular problem in calculus again, that they just ask you to do it, and you have it, a couple of them in your book. And so be careful. They give you this, they want to test you. They give you 3, 5, 7, the index. So the index of the radical is odd. Yes, all real numbers. That's correct. But this is inside, the denominator. So you have to make sure that the, denominator is not going to be 0. So that's why it's going to be everything except 1. Okay, any question? So we ask you all of them in 1 or 2 questions on the test. Because if you want to take calculus, this is going to be very important for you. Okay, we check it. Test this one right at the beginning of the course, in that course. Calculus for business, or just, calculus 1, 2, 3. So that is the domain. Any question? Now, this is one problem that we have to take care of. There is another famous problem for the function. Okay, it's kind of average value that we are going to define later, but we want to test it now. Okay, this is kind of evaluation of a function for the special quotient that we use in calculus again. You have quite a lot in your book, in your assignment. So this is the next example that we have to know. This example is going to be a function would be given to you, see? They give you this function. Suppose the function is f of x is equal to the 5x squared minus 3x plus 7. This is your function. Then they ask you to evaluate the next one. See, they ask you to find this quotient, f of x minus f of 2 divided by x minus 2. You see, eventually it's just like the slope. Remember, the slope is y2 minus y1 over x2 minus x1. But the term the term slope, you can use it for the straight line. This is a function. In future, we replace this notion. We call it average value of the function. Okay, and this is going to be just keep going to get the notion of calculus. In calculus, we have something we call it the derivative of the function. They use this one. This quotient is very popular. It was used by Newton for the first time, and he called it a quotient difference. Quotient or difference quotient, okay? Quotient of difference or difference quotient. Because the top is f of x minus f of 2, the bottom one is x minus 2. Okay, there are many applications of this formula. So we want to find this one. Of course, since x minus 2 is down the denominator, we have to assume that x is not equal to 2, and we wanted to simplify it and simplify and simplify. Again, for the application in future, this is a kind of machine. It's going to be a tool that we use it quite a lot. So we want to get to know it, get practice. Okay, so for the time being, this is just the application of the notion of the function. Substitute, simplify. That's it. This is the way we do it. Okay, solution. So it's a true difference, if you like. My suggestion is I just do the difference first, and then I simplify it. So on the top, I want f of x minus f of 2. So this is my f of x, the function, 5x squared minus 3x plus 7. Then I need f of 2. So replace the x by 2. Okay, replace x by 2. So that gives 5 times. 5 times 2 squared minus 3 times 2 plus 7. Simplify it. 2 squared would be 4. 4 times 5, 20. Negative 3 times 2 would be negative 6 plus 7. Okay, 2 squared 4, that gives you 20 minus 6 plus 7. So we simplify it. What's the result? It's going to be 21. 21. Okay, so that was f of x. That's f of 2. Subtract it. So what do you need? You need f of x minus f of 2. So that's f of x, 5x squared minus 3x plus 7 minus f of 2 minus 21. Okay, simplify if you can. There is a thing to simplify it, 7 minus 21. So the result would be 5x squared minus 3x. Okay, this would be minus 14. Now form the quotient. You see the quotient difference. That's better, to simplify it first and go and substitute. So we divide it by x minus 2, if you like. You see it's going to be f of x minus f of 2 divided by x minus 2. So it's going to be equal to what? Equal to 5x squared, okay, minus 3x is minus 3x minus 14, and divided by x minus 2. You see, you end up with this one. They ask you to simplify it. You see, the nature of these quotients are, the top one, you see the top and the bottom, they would have a common factor. That common factor is x minus 2 all the time. So that gives an idea to quickly simplify it. Whatever you have done the denominator, it must be inside the top. There is one condition for this one. So we use this advantage to simplify. Okay, you're done now. You're not done. Some people, they stop here, but no, you're not done, because they ask you to simplify. So to simplify it, use this advantage that this is, okay, this is x minus 2, whatever it is. It's going to be appear on the top as well. You see, it's automatically there. So this is the way we factor it. Now we can find the other factor right away. So what do you need? You need the 5x squared. This is x. X times what would be 5x squared? X times 5x. Then this number, what is this number? You see this is negative 14. So negative 2 times what would be negative 14? You see negative 2 times a positive 7. 2 times 7, negative 2. You see, you don't have to wait. I know that we can, in algebra, you can use grouping to factor it. But you don't have to wait because you already got one x minus 2 out. So it's very easy to find this number. This is a negative 14. So the negative 2 times 7, positive 7. Now that gives you the chance to simplify. And they already give you the condition that x is not equal to 2, so we can factor it. Okay, x is not equal to 2, so this means this is not 0. So we can factor it. So the final answer would be 5x plus 7. Okay, so this is the result. F of x minus f of 2 divided by x minus 2 is going to be equal to the 5x plus 7. When you are in calculus, we do one more step. Then a step is somehow we put the 5x equal to 2. 5 times 2 would be 10, and 7 would be, okay, 17. That's 17. We call it the slope of a tangent line. It depends what you have. It depends on the f function to get this number, okay, this number through. So very important. So you say what would happen to the negative x, negative 3x? We don't care. Negative x automatically will create it, you see. If you multiply it, when you multiply it, you see 7 times x would be 7x. Negative 2 times 5 would be negative 10x. So 7x minus 10x would be negative 3x. You don't have to worry about it. You will get it. You know that you FOIL it. You FOIL it and you simplify it. When you simplify it, we get the negative 3x. But since you already got this factor done, okay, automatically whatever you have is going to be a correct answer. Okay, any question? So it's, as I told you, it's just the beginning of a long story in calculus. And that's why we practice, because we need it for, for that course. It would be, 3 different types. I just give you 2 types. There's going to be one with the radicals, it can be done, but we do it in calculus if you take that course. Any question? So that's a kind of a type 1. Okay, the function is a polynomial. And there's going to be another type, a little bit of algebra, when the function is a rational function. So we give you the quotient, you see, we give you the formula, we give you these expressions, and then you just substitute, simplify it. In fact, if you don't get it, you see, your common factor is this one. If you cannot get the leftover, probably you miss something, okay? Because always you should be able to factor it. This factor must be canceled out. Okay, let's give another one. The next one is a little bit involved. The reason is when I teach calculus, they have some difficulty in evaluating this one. Okay, so another one. I'm not going to give a radical format, but one of these 2 for the test, or both of them. You see, this is the function. F of x equal to a rational function. How about x plus 1? Okay, over here, x plus 3. That's your function. Now again, we wanted to find the quotient difference. This time is going to be f of x minus, okay, let's see what's going to be a nice number. It doesn't matter. I want to just give you something. Let's say have f of f of n negative 2, okay, divided by x plus 2. We want to find this one. This time x is not equal to negative 2. And of course, we wanted to simplify it. And simplify. Okay, so your function is not a polynomial. Okay, it's a rational function, doesn't matter. We can find it. So again, do as I did for the other one. Form the f of x minus f of negative 2 first. That will help you, to just have a better format. So this is it, it's a solution. Start with the f of x. You have here f of x. This is your f of x, which is x plus 1, okay, over x plus 3. So you want f of negative 2, f of negative 2. Substitute. Okay, if you substitute negative 2, this gives you negative 2 plus 1. And this is going to be negative 2 plus 3. Okay, so on the top, that gives you a negative 1. On the bottom, negative 2 plus 3 would be a positive 1. So the result would be a negative 1. Okay, any question? Subtracted, remember, you want to subtract to get the difference. So I'm going to go to the next page to continue. So I have the f of x minus f of negative 2. I subtract it, I simplify it, then I go back and you take care of it, okay? So this is going to be the case. So I subtracted, it's going to be f of x minus f of negative 2, which is equal to, okay, so when you subtract it, this was x plus 1, and that was x plus 3. Okay, so that was the 1, x plus 1, x plus 3, minus f of negative 2. You see, f of negative 2 is a negative number. Make sure you use parentheses, negative 1. Some people, they miss this sign when they subtract it. Okay, you need a libra of algebra to continue for this one. Okay, so negative would be positive. So that gives you x plus 1, okay, over x plus 3 plus 1. Keep going, simplify it. To simplify it, we get the common denominator. You see it's going to be equal to the x plus 3. On the top is a kind of a cross multiplication. So that gives you x plus 1 on the top plus x plus 3. Okay, I just, it's like adding two fractions. Any question? I keep going, simplify it. So that gives you 2x plus 4. And that would be x plus 3. Okay, so this operation is, in algebra, we call it complex fractions when we simplify it. Now, form that, that you have to divide it by x plus 2. So what you need is f of x minus f of negative 2 divided by x plus 2. So this is going to be equal to, the top would be 2x plus 4, and this is going to be x plus 3 divided by x plus 2. Okay, any question? Now the simplification. Remember I told you that the top and the bottom would have a common factor. The factor here is x plus 2, so you need x plus 2 on the top. How can you create it? You see, look at this top. That is 2x plus 4. Always you would get it. If you factor out the 2 on the top, you see this one? 2 out, that gives x plus 2. And this is x plus 3, and this is going to be x plus 2. Simplify it. If you simplify the number, that would be 1. So you're left with 2 over x plus 3 as the final answer. Okay, so I got the quotient difference, f of negative 2 over x plus 2. Usually give you a polynomial type. For the test, I just wanted to see how you handle, this type of idea. In your book, they give just 1 over x because they don't want you to get involved. But just give you the taste of what is going to be, in future if you want to take those courses. Okay, any question? So one quotient difference, and as I told you, in future this would be changed into the so-called average value of a function, and we are going to check it again. If it is going to be a kind of a moving object, we are going to introduce this one as the average velocity. It's quite a lot for this type of ideas. Okay, any question? Now, question?
Yeah, what happened to the 4?
Where is the 4? No,
On the
I factored on the 2, you see.
2x plus 4 over x plus 3.
You
What
see,
happened to the 4?
I factored the 2
Oh, okay.
because you need that, you see, you need that x plus 2 on the top. So I factor it out, so I have the x plus 2 and the x plus 2 be able to simplify it. Okay? If you don't get it, this means you missed something. You must have that common factor on the top. Okay, so that was just an indication of what's coming in future. But you see, when we use this type of formula in calculus, and I'm going to explain it a little bit later on for you, that this is average value, if you like, average velocity. But when you derive, there is going to be a case that you'll be given a ticket, if you like. So when you be given the ticket, this is not average velocity, because the average velocity is what, 65 miles, 70. But you'll be given a ticket not at the average, at the time that you're driving. You see, if you want to do that sort of problems, you have to modify this formula a little bit. So that's why in your book, they give you in your exercise, okay, I'm going to show you 2 types of quotient difference. And it's happened again for the calculus. This is one format. The other format is the one that, we call it not average velocity. In future, we are going to call it just the velocity or instantaneous velocity. Okay, I'll give you a little bit, I cannot get through that one, okay, but this is the way we are going to do it. Okay, we call it predicted rate of change, if you like. So it's kind of prediction. You see, calculus is prediction. In science, you predict. You're given a ticket. When you get a ticket, it's not why the reason that you've been driving, let's say 95 miles. They give a ticket to prevent it. They believe that at this time, from this time up, your velocity would be increased by the rate of 95 miles per hour. That's why they give a ticket right away. If you want to solve those type of problems, you have to modify this one. This is going to be a modification. So again, we stay with the polynomials, but you have to know both of them. And in your book, in fact, you got more problem of this type rather than the one that I did. Okay, so this is just one problem, but I just divided it in 2 parts. So what is that version? That version is, this is it. Suppose, again, for both of them, I go with the polynomials on the test. I just did this one for your information. As we give you one polynomial, 2 formulas. We wanted to simplify. The first one was given. Now, let's take this one. Suppose f of x is equal to x squared minus 3x plus, let's say, plus 2. That's your f of x. Now we would like you to find this one and simplify it. Find. Okay, find. What is this? This is the version that we are going to use again in future. They ask you to find what is f of x plus, it's going to be something, we call it h. Okay, h is a number, a small number, minus f of x divided by h. But it's the same thing. You assume that the h is not equal to 0 and simplify it. And simplify it. You see what's the difference between these two that we did? For the other one that we did, remember, it was f of x minus f of 2. So it's between x and 2. This is the way, you know, the camera of the police car will watch you. You see, the camera are interested in, police are interested to see what's happening to you at the time x, if you like. Okay, at the time x means at the time that you meet the police car, if you like. So the camera would watch you. As soon as the camera identify you, the camera start looking at you in one interval. So what's your interval? You see the interval is from x to the x plus h, if you like. So if it's going to be 1, very close, you see, very close. If they see you at x equal to the 5, the camera will watch you between 5 and 5.002. Okay, the number is very small. But as you drive closer and closer to the camera, closer and closer to the police car, this h is going to be smaller and smaller. So eventually this x plus h, which is 5.0001, would get closer and closer to the 5. So as soon as you meet the police car, these two would coincide. Okay, these two would be the same. So that's why in that case, this quotient over here is not going to be average velocity, if you like. It's going to be your velocity at the time of the meeting in contact with the police car. And the camera would register 95 miles, and then you begin a ticket. That's the best example of, you know, everyday life. They made me explain this type of idea in calculus. And that's why the people wonder that why we have two formulas. One of them is this one, you see? Look at this one that I give you. You see this? This is x and 2. You see, in this case, your x getting closer and closer to the 2. So the one that we did over here is you want to get to the x, okay, the meeting. You want to get to the x, so you estimate it. You start from x plus h, and then you just keep going. So if it's going to be, if you're driving on freeway, this is your position, and this is going to be, we call it the rate of change. Rate of change are your velocity. If you invest money, and this is going to be next 6 months, and this is going to be your interest from your stocks, if you like. If you want to know exactly what would happen to your money after 6 months, this is the way you do it. We estimate it. We estimate it with the 6 months and 6 months and 6 months and 4 days up or down. So this is the part of the science that we use. So we call this one, I will call this one, when I teach calculus, we call it predicted rate of change. It's kind of prediction that we're going to do. And it can be used all over the places. If you are in biology, for example, this f of x is going to be the growth of the cancer, okay, cell, if you like, after 5 hours. Okay, after 5 hours. But if you want to predict what is going to be the rate of the growth of the cancer cell, you get the 5 and something close to the 5. So this number would be give you the rate of change in the growths. It's going to be very important for you. If you know that the rate, is going to be something 100 units per hour, then you can prevent it. You can apply some action. So it's all over the places. It's a cost function, revenue function. That's why when I teach college algebra or pre-calculus, my student asked me that what we should know for calculus. I say 2 problems only. This is one of them. The other one is piecewise defined function that you're going to see. They are surprised. So, I said, yes, if you get a good understanding of this one and the piecewise defined function, you'll be fine on that course. We don't need anything else. We don't need any hard algebra, if you like. So that's why you are going to see these, these expressions really for future. Okay, so but your job is just to find it for us. Okay, we have some shortcut in future. We have some formulas for it, but fun is you don't know it and you have to do the algebra for us. Okay, now when it's going to be h, it's a little bit more algebra. You got to be patient to simplify it. Okay, but it's not bad. Okay, are you ready? Let's do it. You have to find the top, okay, bottom, and then divide and simplify. Solution. Okay, solution the top. You see, this is your f of x. So you have to find f of x plus h. This is the one that people they don't like. You see, this means you go to your function, you replace the x by x plus h. You see, it's like a box. You see, it's like a box. Your function is x is not important. X is a name. So your function is like, input a square, the box a square, minus 3 times the input plus 2. What is the input? X plus h. So it's going to be, you need a parenthesis, x plus h squared. Okay, minus 3 times the input. What is the input? X plus h plus 2. Okay, so you got the x, you replace the x by x plus h. You have to simplify it. You have to square x plus h. Okay, if you know the square of the binomial, you go for it. Otherwise, you multiply by itself. X plus h times x plus h, FOIL it. But the square of the binomial is easy, we already used it. Okay, so what's the square of the binomial? Is x squared. You multiply these two together, you see. 2xh, okay, plus 2 times x times h, plus the square of the h squared, done. Okay, we give you a square, cube 4/5 is going to be very complicated. And we are not interested in. Okay, again, you see, x squared. 3 times x times h. Okay, 2xh. Plus the square of a second one, which is h squared. Go on, multiply the 3. It's going to be minus 3x. Okay, minus 3h. And the plus 2. That would be f of x plus h. Any question?
Yeah, is stuff like this going to be on the test, or is this just so that we can...
Of course. No. This would be on the test right away.
Yeah.
And this is a very crucial part that we have to know it for future. And you have a series of problems in your book. Okay, we give you just a polynomial, the fractional one would be complicated. There is a radical one, but since you are in college algebra, even if you take calculus for business, so that would be enough for you. But otherwise, you have to check it. Okay, and it's not a big deal really. You will see it in a minute. Everything would be simplified. Okay, so it's going to be a squared. So it's squared x squared 2xh plus h squared, done. Negative 3 minus negative 3h. Nothing would be simplified here. So the next row is f of x as we did it. So our f of x is x squared minus 3x plus 2. Remember, subtract. What's a subtraction? It's f of x plus h minus f of x is equal to, you write the first one minus the second one, x squared plus 2xh plus h squared minus 3x minus 3h plus 2 minus, use parentheses, otherwise you will lose everything. You see, this is going to be the one. So this part, you see this part that I put over here, you see this part is the first part. It's f of x plus h minus, and this part is the second one, f of x. If you change this sign, most of them would be cancelled out. Okay, so we have to rewrite it again, equal to, some people they miss that sign, x squared plus 2xh plus h squared. Okay, minus 3x minus 3h plus 2. Apply the negative sign. Make sure you apply to all the terms inside. Some people, they miss it. They just apply to first one. No, it's minus x squared. Okay, negative positive plus 3x. Negative positive negative, that give you minus 2. Any question? So all the x's would cancel. You see, negative 3x positive out. What else? 2 out. Okay, what else? What else is going to be? You
Squared.
see, squared. All these x must disappear. And the rest are going to be, everything would contains an h for the rest. You see 2xh, h squared minus 3h is going to be the leftover, if you like, okay? So I'm going to go to the other side to just get this one. Okay, so this is what we did, f of x plus h minus f of x, and that bit, okay? Everybody got this one right? Okay, so the leftover is 2xh, h squared minus 3h, okay? 2xh, h squared minus, okay, this is it, plus h squared minus 3h, minus 3h. Okay, remember you divide by h because the quotient difference is f of x plus h minus f of x over h. This is where you get the common factor and you simplify it down. It's a 2xh, h squared minus 3h over h. Remember, I told you, you should have a common factor, but the common factor this time is h, because the bottom is h, so pull out the h from the top and simplify. H odd, that give you 2x, h minus 3 divided by h. These two will cancel out. You get 2x plus h minus 3, the final answer. See, so I rewrite it, f of x plus h minus f of x over h is going to be this quantity. You see, this is where you meet the camera, if you like. So what the camera will do, the camera will change the h into the 0 because you meet. So that gives you 2x minus 3. This is the extra action that you do in calculus. And that will give you a very famous formula. Okay, so two version, we call it the rate of change version, which is this one. And the other one that I gave you is much easier. Okay, and when you are in calculus, either one can be used. In those books, like your book, they like this one. They don't discuss the first one that I gave you. But the first one is really just history. And they go with the first one and get to this second one. Okay, you have quite a lot in your book. But we just assigned a couple of them. There are going to be a radical 5, rational type. Those takes times to handle it. And it's too much for this course. But you must know one of them, as I told you. It's a very popular case, and we give you one question on the test, 2 parts. The first part is just the first version that I did, and the second part, we call it the H version. So let me just show you the one that you have in your book. They like it quite a lot. They talk about it quite a lot for you. You see? That's it. Your book, this is, and I have assigned some for you, you see? This is going to be where you are going to see it. You see, look at this. Both version in your book. This is the version that I gave you, okay? And this is the other version. In your book, they replace the x by a number, see? The one I did is, this would be too much. Okay, too much, these are going to be, the one I did is this one. Your book make it easier. They don't put the x, they put the number. So I do one of these numbers for you, and this is the way I'm going to question you. Okay, we are interested in just the polynomial type 1, 2, 3, 4 up to the 80. These are going to be very much more involved. We need a little bit of algebra. It would be too much for this course. So we're just focusing on the polynomials. We give you one of them, and we ask you in two different versions. So I'm going to give you this one, but I put it into two different versions so that you know how we're going to test it and the way we're going to see it. Okay, so you see that's the name, difference quotient. Difference quotient. It was done by Newton, Isaac Newton, for the first time, but then it's happened to be very important. But they use it for the velocity, the average velocity, and then instantaneous velocity. But later on, it's happened to be very, very popular. Okay, so I'm going to do one of them for you so that you know what we expect you to do for us. I do number 78, but I change it a little bit so that you get there. This is how we're going to get it on the test. Okay, this is it. So this is section, okay, this example is from section, okay, section 2.2. 2.2, I do 78. Make sure you do 77. Okay, just pick one of them as those 5 problems so that you practice and you be prepared for it. Okay, we give only a polynomial type, nothing else. Okay, so they ask you to find, this is it, this is the way we are going to talk about it. If f of x is equal to, f of x is 5x minus x squared. They simplify, just give it numbers, so we go with this. Okay, if this is going to be the case, they ask you to find, okay, find the difference quotient, or just basically that's what it's asked for. They ask you for f of 5 plus h, okay, minus f of 5. It's a number, it's much easier, over h, and the condition that h is not equal to 0, and they ask you and simplify. Okay, simplify your answer. Simplify your answer. Okay, that's how we like it. It's much easier when it's a 5. Okay, are you ready? You have to substitute, just don't put them all in the fraction form. Simplify it first as I did it, and then at the end, it's going to be easy case. Okay, are you ready? Let's go. You see f of 5 plus h first, and this is your f of x. So this is it. You want to find f of 5 plus h equal to, you see again, you think about it like you put it into the box. You may call it z if you like. So what's your function? Your function is 5 times the input, 5 times the box, minus input squared. Depends on the input. If the input is x, 5x minus x squared. Input is, a chair, 5 times the chair minus chair squared. You see, it depends. But the input is this box, 5 plus h. So it's going to be 5 times box, 5 plus h. Okay, that's it, done. Minus box square, input square, open up parentheses, 5 plus h, all squared. Okay, so that's, you replace the x by whatever you have. Now you have to simplify. The simplification, you got to be careful. You multiply the 5 times 5, 25, 5 times h, 5h, minus, make sure to open up parentheses first, then. This is that square that I told you, square of the binomial. How we're going to do it? 5 squared, 25. You multiply these 3 numbers together. 2 times 5 times h. 2 times 5 times h. 2 times 5 is 10, 10h. 10h plus h squared. Okay, square the first one, 5 squared, 25. 2, bring it down. 2 times 5 times h. 2 times 5, 10, 10h. Plus the square of the h squared. Distribute differences, 25, 5h, subtract, minus 25, minus 10h, minus h squared. Any question? Make sure to apply the negative sign to the three terms. Now simplify. You see 25 and 25 would cancel out. It's equal to, we have the 5h and the 10h. 5 minus 10 would be negative 5h minus h squared. That is f of x plus, okay, that was f of x plus f of 5 plus h. Okay, so it's f of 5 plus h. Any question? You want to subtract it from f of 5. So find f of 5. F of 5, go to the function, substitute. This is your function. 5 times 5 minus 5 squared. Okay, 5 times 5 minus 5 squared. Okay, so 5 times 5 would be 25. Minus 25, 0. Nice. Now, the difference. Okay, find the difference. Difference is f of 5 plus h minus f of 5 equal to negative 5h minus h squared minus 0. So 0, nothing to simplify. That gives negative 5h minus h squared. Okay, when it's a number, it's not x, that gives you the chance better to simplify. Okay, so this is just the top of the fraction, top of the quotient. So you divide by h, and simplify it. Okay, so we get the f of 5 plus h minus f of 5. That gives us negative 5h minus h squared. Divide by h, and then simplify, and you're done. Okay, so this is what you have. You can write all of them at once, and some people they do, but I prefer this one. F of 5 plus h minus f of 5, now divided by h, is equal to, the top is the one that you got. Okay, negative 5h minus h squared divided by h. To simplify, common factor. What's a common factor? h. So a factor of the h from the top. So h out. So that gives me negative 5 minus h divided by h. H and h was cancel out. We get negative 5 minus h, the final answer. Okay, if you are in calculus, you replace h by 0, that gives me negative 5. So f of 5 plus h minus f of 5 divided by h is equal to what? Negative 5 minus h, and then you're done. You see, this is the way you have it. When you want to create a formula, you go with the x. But when it's a number, it's not a big deal. So your job is, don't miss that first part. When you see, when you simplify it, this is where usually make a mistake. When you replace it by a box, 5 plus h, nicely simplify it, and it always can be done easily. Okay, that is a different quotient. Any question? Let's see what's the question. And make sure you know this one. We give you not only on this test, also we repeat it on the final. You say, can you also have the answer as yes? Yeah, you can have negative h minus 1, minus 5, or just leave it there. Okay, we give you one not only on this test, also we repeat it on the final. This is one of those terms that, because we know that we need it for future. That's why we give it. Okay, this is 8:27. I give it 10 minutes. We come back. There are a couple of more things about, this section. We can put them together. Some easy definition. Just make sure that we are ready for the test. Okay. Any question? So 10 minutes, we come back and we try to finish it, a couple of definitions, but we are done the main part. Okay, we are going to continue, give you more example or the property of the function. Okay, so we talk about the domain, we talk about this quotient difference. That's going to be very, very useful. Okay, any question? Now, when we talk about the function, you see the one that we did so far, the the equation of the function was given to you by the the definition of a function would give you in terms of the relation. This relation happened to be just one equation. But in science, okay, in science, sometimes you have to define a function in different steps with different functions, with different equation. If this has happened, the function is going to be called a piecewise defined function. So that's a very important example of the functions for science. Okay, so we introduced this one, and then you have a series of the example on the piecewise defined function too. Okay, so we are still in that section 2.2. Okay, so what's going to be piecewise defined? Okay, piecewise defined, wise defined, defined functions. In the in the history of calculus or history of functions, at the beginning they believed that a function must be defined by one equation only. We say y equal to the x squared. But later on, it was the application in physics, especially. They have something that's happening in physics and they want to justify it. They find out that they cannot do it with one equation. Okay, and eventually they accept it. So if you have a function and you break the domain and define the function by more than one equation, you say, oh, this function is piecewise defined. You see several pieces, and each piece is going to be defined separately. Okay, so this is going to be the idea. So a function, okay, a function f that is defined, let's say by several, okay, by several equations, okay, is going to be called, a piecewise defined, piecewise defined function. Okay, we cannot do it with one equation. We need several equations. Okay, give you example. You say consider this function. Suppose f of x is equal to the x squared minus 2x, but when x is less than 2. Okay, x is less than 2, but it's going to be defined by, let's say, a square root of, okay, defined by a square root of x plus 3 when x is greater than or equal to 2. Okay, so your function is defined by two equations, okay, the first one and the second one. So it's like, this is like, what you did really is, this is the number line. Okay, if this is going to be the case, let me finish it. Then f is a piecewise defined function. A piecewise defined function. You see, the idea is, you see, the domain of this function, the natural domain is function is all real numbers. See? What we did over here, we just partitioned it at 2. So this is 2. If your input are going to be less than 2, So your function would comes with this definition. You see, it's y equal to x squared minus 2x. That's a relationship between x and y. But if your input are bigger than 2, so you have to use a different equation. So that give you, okay, that give you the equation. So it depends, okay, it depends where are you? Are you coming from the first step or the second step? But this is a function. Each one is going to be separately a function. A function would do different formulas if you like. Okay, any question? Now what we wanted to do is we wanted to be able to work with this function. So I would like you to be able to find some values of this function for us, okay? So suppose this is going to be the case. You see, note that they give you the value and then you're going to find it. Let's try some. Suppose you want to find what is going to be f of, okay, f of 1. So you have to check to see where is the 1. Is it in the first region or is it in the second region? You see 1 is less than 2. 1 is in the first region. You see this is 1. Since it's a less than 2 in the first region, you're going to use this formula. So replace the x, so that give you 1 squared minus 2 times 1, which is going to be 1 minus 2. The result would be negative 1. So f of 1 is equal to the negative 1. Okay, you cannot use both of them. There's no overlap if you like. So you have to use only one. So you decide where is this number is coming from. 2, 1 is less than 2. So it's below 2. Since it's below 2, you have to use the first formula to get the numbers. Okay, any question? But for example, if you want to find, let's say, f of 1, sorry, if you want to find the f of 6, you see the 6 is here. In the second region, 6 is bigger than 2. So if you want to find f of 6, you have to use the second formula. You cannot use the first one. So we go to the second one and replace the x by 6. That gives 6 plus 3. Okay, 6 plus 3. So that gives a radical 9. And the radical 9 is equal to 3. So f of 6 is equal to 3. Okay, so it depends in which region are going to be to check these numbers. The special one is just 2. Okay, the boundary. If you want to find f of 2, you have to go back and have a look. Where can you put x equal to 2? You see, you cannot put it over here because there is no equality sign. But you can put it here because there is equality sign. Okay, so if you want to find f of 2, you've got to be careful to which part are you going to use. F of 2 is equal to, okay, we have to use the second part. So it's going to be radical 2 plus 3, which is going to be radical 5. So f of 2 is equal to the radical 5. Okay, so you got to be careful when you're working with the piecewise defined function. You cannot use both equations. You can use only one of them. Any question? It's the one that we use in science quite a lot. Can you give us an example of the piecewise defined function in everyday life? That we have to use, different formulas for different occasion. Any suggestion? You see, your cell phone is one of these functions. Because your cell phone, you have a contract, for example. X is going to be number of the units. If your contract is going to be something like 700 units, if X is less than 700, you already pay $65. But it's going to be over if you go over. If X is going to be greater than your limits, 700 units, you know that they charge you more. But they charge you with a special formula. So your cell phone is going to be a piecewise defined function because it depends on the, okay, if your contract is going to be, if your contract is going to be unlimited, so it's just a function. Okay, you dial and you pay. So that's a function. But if you have a contract with restriction, that give you a piecewise defined function. Okay, this is one of them. The other one is, what's that? Post office. You see, the post office function is, this is piecewise defined. Why? Because when you go to the post office, okay, X is the weight of your parcel, whatever you have, letters. So you put it on the scale. When you put it on a scale, it depends. There is a range. If your X is between 0 and 2 ounces, for example, they charge you to what? 53 cents, whatever. But if it's going to be heavier, you have different formulas to do it. So the post office function is a piecewise defined function. It's a very good one. Any question? Examples? Can you give us, think about any example of this type of operations in everyday life? You know, because the machine that you apply in several formats. Okay, so your cell phone, your post office function. The other one is tax function. The tax function is piecewise defined because there is no one formula for the tax. You know that. X is your income. If your income is less than what? Less than $30,000, you pay only 10%. So 10% of your income, 10% of the X. But if your income is going to be what? Bigger than 30,000, between 30,000 and $100,000, for example, you may go to the 20% bracket. You see those tax brackets? It's just a function. It's a piecewise defined function. So the tax function is a piecewise defined. Post office function is the one. Cell phone is one. Anything else in everyday life? You have some good one at your home. By the end of the month, what do you do? What type of bills do you have?
Mortgage.
Okay, the mortgage. Anything else?
Electricity.
Excellent. Utilities. You see, the utilities are the best piecewise defined function. If you look at your utilities bills, okay, electricity, gas, okay, they nicely explain it to you. Yes, gas, what it is, that's one. You see, they explain it. They tell you, oh, this is the reason that, you pay more. They say the number of the X is going to be number of, let's say, kilowatts. If there is a range, if it's between, let's say, 1 and 0 and 200s or 300s, I don't know, they charge you something like, 43 cents, dollar, etc. But if you go higher, they have different brackets, okay, different bracket to charge you more. So it's, and it is nicely, okay, nicely explained for you. It's the same for the water, electricity, gas. So all the utilities are nice piecewise defined function. So anything connected to the everyday life, we see most of them really are piecewise defined function to get these numbers. So such important functions in science. And it was, as I told you, if you go back, search on internet, just click concept of the function. You'll be surprised to see so many of these type of functions that discussed at the beginning. They didn't believe it. But today in a statistic, all the functions are piecewise defined. Probability is piecewise defined function. And if you take calculus or any other courses other than this course, the function that you have to live with is piecewise defined function. Okay, that's why we like it. We like it at this level. We just work with it. Okay, just we give you on the test, we give you one piecewise defined, and we ask you to evaluate it. It's very easy. The suggestion, just put them on the number line. You cannot use two of these at the same time. There is only one possibility that if you have equality, you are not going to have it. But if x equal to 2, if the first part and the second part happen to be exactly the same, that's okay. But otherwise, you won't get it. Each number give you one input, give you one output for the piecewise defined function. Okay, so pay attention. Very nice function, and it's all over the places. Okay, for the piecewise. Even vending machine is a piecewise defined function. Okay, they ask, select. When you select, they bring the soda machine. The soda function, we give it the soda. Anything else, they change it. So such a interesting function. We come back to it and we graph it, but would be too much for this time, if you like. So that's a piecewise defined function. You will see it on your practice one. So what else can we do with this function so far? So we give you especially that difference function, piecewise defined, and the domain and the domain mostly. So we can just give you a couple of things from 2.3, not all of them. Something about identifying the function. Remember, we give you an equation and we ask you if it's a function. You say for each x, you get only one y out. So that gives you something about the graph of the function. So just we have a little bit more time. So let's get this property of the graph. That give you a couple of easy definition that we can give you on the test. Okay, so what is going to be the graph of the function? The graph of a function. Some people like geometry, so they love to talk about the function from geometrical point of view, the domain that we did, the value of the function that we did. Let's see how we're going to organize this. Okay, so the graph of the function is simply, that it's going to be just a collection of points. So if y equal to the f of x is going to be a given function. Okay, is a given function. Then you know that the graph is just a collection of points. Then the collection of all points x comma y satisfying. Okay, satisfying this equation is what? Is the graph of the function. Is the graph of the function. It's like the graph of the equation that we did before. Okay, so we are going to graph a different function in future, but just one easy example that we did it before. So we want to sketch this graph. Okay, sketch the graph of, the function is y equal to the x squared, like we did it before. I need it. That we just pick a couple of points that satisfy this equation and we connect them together. Because it's x squared, so we know that we are going to have a curvilinear graph, if you like. So the solution is going to be, okay, just pick some points. This is x and this is y equal to the x squared. Just, a couple of numbers would be fine. X equal to the 0, y would be 0, 2, 0 squared. And 1, that give you 1. Just a negative 1, just would be 1 again. Okay, you are going to use this graph several times. So this is it. So you look at this point, 0, 0, this is going to be 0, 0. Then you get a 1, 1, this is 1, 1, 1, 1. And we have a negative 1, 1, this is going to be negative 1, 1. So that's a negative 1, and this is 1. Okay, connect, it's a curvilinear. So this is going to be the graph of the function. Okay, for the time being, when we go on, we have for the specific function, we are going to have a specific definition to get that. Now, what we are going to be interested in, this is, you see, y equal to x squared is a function, so we graph it. So the thing is, if a graph, we already talked about, if an equation is given to you, you can tell us whether that equation would represent a function or not. Remember, for each x, you must get only one way out. So that for each x get one way out, give you a kind of test to find out, okay, whether the given graph would represent a function. Okay, so this is the idea that we are going to be interested in. Okay, so the question is going to be, you see, this is a question that we're going to answer, how we are going to identify that the given graph would represent the function. Remember, these setup points that we have, these are order pairs. Okay, these are order pairs. What was the condition? The condition was, if we give you two order pairs, they cannot share the first component. Share first component means for each x value, you must get only one y value out. If I give you x equal to 2, what type of line is this x equal to 2? X equal to 2 is a vertical. No, vertical. You see, if I give you x equal to 2, that's going to be a vertical line, You see, if this vertical line would intersect the graph at one point only, that graph is a function. If I give you 1x and then you give me 2y's, this means that vertical line intersects the graph at more than 1 point. This easy condition that we put them together give us something that we call it the vertical line test. Okay, so we need this one. What is, this is the foundation of whatever you want to do in geometry of the function. What is the vertical line test? This is the same thing that we did before. For each value of x, you get only one value of y. Value of x give you a vertical line. One value of y means this line should intersect the graph at one point only. You see, this is going to be the idea. The idea is the equation y equal to the f of x represent a function, represents y as a function of x if and only if. Remember, for each x value, we get one value. X value give you a vertical line. Or we say that we cannot shade, those order pairs cannot shade the first component. So if and only if there is no, okay, or no vertical line, if and only if, let's say there is, if and only if there is no vertical line that intersects the graph of f at more than 1 point. You see, that's a great interpretation of the of those things that we talk about it. So if you get a vertical line, if that vertical line intersects the graph at more than 1 point, okay, so in that case, this is not going to be, okay, it's not going to be, okay, a function. Okay, so we draw the vertical line. That vertical line can intersect the graph at 1 point or never intersect. We call it the vertical line test. So that's exactly, that condition that for each x, you can get only one y out to get these numbers. Okay, so in this case, if you like, I repeat it again. In this case, okay, each vertical line intersects the graph of the function y equal to the f of x at most at 1 point. 1 point means never or just 1 point. That's quite interesting, geometric interpretation of that one that we did before. No two order pairs would share the first component. Okay, so what's going to be the example? Some graph would be given to you. I won't give you this type of graph, but it's going to be used in future for some other purposes. Okay, so easy format. So they give you some graph and they ask you to determine if the given graph represent y as a function of x. You see, this is the type of the question that we have. Just check those vertical line. You see the first one. See this graph. If you pick any vertical line, that will intersect the graph at 1 point only. You see, take any vertical line you like. The intersection is just 1 point only. So the answer is yes. Y is a function of x. Okay, because each of these is x. You get one x, you see one y. 1x, 1y. So no sharing. But if I give you this one, see, look at this one. If I give you a vertical line, so I give you the x, but you give me 1y here, I can call it y1, and then you give me 1y here, y2. So what I have x comma y1 and x comma y2. You see, they share the first component. It's not a function. Okay, these two, just for your information, have a common, if you like, a common x value. So no, it is not a function. It is not a function, or does not represent a function. You see, it's the same thing that we did before for the order pairs. Okay, for the order pairs, you get this one. This is just a curve. It's not a function. Okay, and you know that the famous one is a circle. You see, if you get a circle, this is going to be the circle. This is a circle. It's very bad. It is a circle. It's not a function. You see, vertical line intersect at 2 points. There are quite a lot of vertical line that intersect. You see another one intersect at more than 1 point. So no, it is not. Okay, it is not a function. Okay, so it's not going to be a function. Each vertical line might intersect the graph at 1 point only. Any question? Again, you can stay with the graph. You can find the domain and the range with the graph. Okay, just give you one more example. These are all graph one, as I told you. I'm not going to give you any graph, but it's nice to know for these functions. Okay, so another example, the last one that I'm going to talk about, because I'm giving you one problem that was a little bit related to this idea. That's why I want to end up with this one. So again, the graph would be given to you. They ask you to find the domain, okay, and range, of the function. Okay, find the domain and the range of the function with the given graph. With the given graph. This would be interesting for future again. Remember, the domain is the x values. X, you go to the right, to the left. Range is the y value. You go up and down. You see, look at this example. You see this example? Going to the right, to the left is a negative infinity to positive infinity. Okay, going up and down is going to be positive infinity up. You see positive infinity up, negative infinity down. If you want to find the domain, you see the domain is going to be x is going to be in the domain. If you put x here, get the vertical line, you intersect the function, so that give you one numbers into the range. So this point is on the domain of the function. You see, if you pick another one, is in the domain. Pick another one, is in the domain. It's the same thing for here. You see, the same thing for here. So you go to the right, to the left, always you are on the, okay, you get the points which are going to be on the functions, on the graph of the function. So this means the domain is all real numbers from negative infinity to positive infinity, or just R. Any question? So going to the right, to the left, no restriction. That would be domain. Domain is got the value on the x-axis. What is the range? Range is the y values, the output. Y is here. Okay, so as you can see, there is nothing here. So y is not a negative number. But if you start from here, you see, you get the value of your function. You see your function are going here. You see these lines, that. So the value of your function is start from the 0 and keep going up. So if you like, if you like, this would tell you that x is between negative infinity and positive infinity. Over here for the range, you realize that the range is going to be between 0 and 0 and positive infinity. So the range is going to be 0 and positive infinity. Why? Because your y is between 0 and positive infinity. Okay, going to the right, to the left, this is the domain. Going up and down, this is the range. And this is all we can have it because of that vertical line test. Okay, just give it one more. Depends on what you want to do in future. These are going to be important, but we're not going to use it quite a lot. But this one is going to be interesting. It's the same thing, but I'm going to, okay, a little bit. So this is your function, but this function is interesting. You get the here only. They start from -2, and this is only, it's a +2. And this top one for the y is 4. You see, look at this one. So if you want to find the domain, you go to the right, to the left. How far you can go to the left? See, x is between +2 and -2. Because they put the restriction for you. So this means the domain of the function. You see, this means the domain is going to be between -2 equal to -2 and +2. You see, this one, there was no restriction. You can go to the right, to the left forever. But they restrict it here. And the value for the y, you see, you start from the 0, you go up to the 4. So your y is between 0 and 4. So this means the range of the function is going to be between 0 and 4. You see, this is going to be the difference between the first part and the second part. Okay, so we go to the right, to the left. If you stay on the function, the value for the x is going to be the domain. You go up and down. That gives you the value of the y. The value of the, remember, the input, output. The x value is the domain. The y value is the range. Okay. There are a couple of more things, in this. There are some bits that we put them together, but we don't. We don't need it now. So basically, the test is going to be mostly covered by that section 2.2, really. Okay, that's it. Any question? So check for practice test number 1. Don't miss it. You should get full grade, full points really on this test. We already got the quiz. So if you already got your quiz, correct your mistakes, because the question similar to the quiz would be repeated again. So that's 5 questions from the quiz, and the 6 from this new parts make it to the 11. I post something for you. We go over it on Monday. Then the take-home quiz number 2 that's going to be posted is yours for extra point and for the guide for the test. So I go over everything on Monday and give you the test on Wednesday. Okay, any question? So wait until tomorrow afternoon or tomorrow evening. Then if you see anything is missing from the, your quiz, the take-home quiz and the assignment, send me an email so I will correct it for you. Okay?
Yeah, I have a quick question.
Yes.
When do you know to use brackets versus the parentheses?
You see, bracket means you have it. You see, if it's a solid point here, you see they are solid. So we have to use a bracket.
All right, cool.
Okay. In that case, they put a hole here. If you put a hole here, then you know that you shouldn't get this point. Then you make it parentheses. Okay? It's like the one, when it was a rational function, remember the zeros of the denominator, we use parentheses because we cannot have. But over here, there is no hole. That's the one. Okay, any question? So no assignment would be collected on the day of the test. Just come for the test and bring that take home. We talk about it on Monday, of course. Okay, that's it.
How much time will we have for the test?
The lecture hour, 2 hours.
All right, thank you.
Yeah, that's going to 2 hours. Quiz, it's short one, but the lecture hour, we give you 11 questions, remember. We give you 11 questions and you answer 10. You better answer, of course, all of them. You should be able to do it in 2 hours, it's fine. And get enough time to submit, You don't need them more, but unless we may give you, but 2 hours. Yes, 2 hours. Okay, any question?
Yeah, did you already enter the homework points and the extra credit?
No, not all of them,
Oh, okay, cool.
because I'm just looking for. This is it. You wait until tomorrow evening. I have no class from 4 o'clock. I check all of them. If you don't see anything by tomorrow evening, if something is missing on your side, let me know. I have some other emails from you that I haven't looked into it. But I do everything tomorrow before the test. I want everything to have them. Then if you don't see it, email me. Then we can take care of it. Okay? No, for the test is going to be whatever we did so far. Okay, somebody asked whether this is going to be just section 2. No. The quiz, okay, whatever we did so far. It's your quiz, and from the new topics mostly what? Section 2.2 really, 2.2, 2.1. So you get 5 questions from the quiz and 6 questions from this section 2.2. You will see the review. Okay, whatever it's on the review, you get the one. Okay? And that's it. Have a good night. Take care. See you on Monday.
Good night.
Okay, bye-bye. Have a good night.
Hey guys.
Bye-bye. Take care. Bye-bye.